Hi, and welcome to the first day of Keysight University Live. I'm Daniel Bogdanoff, and I'll be your host for this event. I am super excited to get started. So first, we'll briefly cover the event's activities so you know what's happening and when. Every event day, this webpage will update and we'll have a fresh live stream right here live from Colorado Springs at 10 a.m. Mountain Time. That's -6 UTC, so take a moment, put a reminder in your calendar for every day this week. Each live stream will have a couple things. First, we've lined up some really interesting interviews with experts covering all slices of the electrical engineering and electronics space. This is your chance to catch up with some of the industry trends and see what's happening today on the cutting edge of tech. We'll cover areas like RF simulation, quantum electronics, 5G, and a whole lot more. In each live stream, we will also draw that day's test gear winners, including today. I'll go into more details on that later, but there are over 100 test gear prizes, including the brand new Smart Bench Essentials that officially launched today. There's a brand new benchtop DMM, power supply, and function generator. These use the same technology and chipsets as some of the higher end gear we make. They are great. I've had some time to use them over the last couple months, and they feel just like the higher end equipment that I get to use. Like I said, today is the official release of these, and you can see more information about them in the links below and later on in this stream. You can also win them in the drawing, but you don't have to leave it to chance. We're running the Smart Bench Essentials Challenge. There's a link lower down on the page. Tell us why you need a bench setup, and we just might send you one. Judges will review entries and we'll give away one bench setup like this per week for the next 6 weeks in addition to our drawings. So get your entry in quick on the contest page. Like I said, there's a link for that below. Since we're live, I'll also be taking some Q&A questions in the chat and answering them at the end of today's stream. The team here is monitoring questions that come in and sending them over to me on my laptop. So get your questions in now and I'll get them later at the end of the stream. Lower down on this page, there's also a non-live stream video. This is going to be a how-to tutorial or experiment of some type. Each day's will be different. Today's covers everything you should have in an electronics lab, and tomorrow we're going to test the urban legend that holding a wireless car key fob up to your face increases its range. So tune back in tomorrow to find out if that actually works. If you miss a day at some point, you can still browse through different days' pages using the navigation buttons near the bottom of this page. And if one of those days' topics piques your interest, we've also handpicked a related Keysight University on-demand course so you can go and keep learning. It doesn't end here. There's a link for those at the bottom of the page as well. Every course is free, video-based, and under an hour. Today's interview is with John Kenny, one of the R&D leads who helped make this new gear a reality. He spent decades working on these and their predecessors and has some really interesting insights into product design and what makes a great product stand apart from just an okay one. Let's jump into that now. We're joined today by John Kenny. He's the technology manager of the Electronic and Industry Solutions Group here at Keysight. And as we have released these new Smart Bench Essential products today, I thought, why not bring on John, who's definitely had a hand. John, thank you so much for being here today.
No problem. I love doing this.
Can you give us a little bit of background to what you've done for HP Agilent at Keysight and what hand you've had in the Smart Bench Essentials products that we just released?
Sure. Well, I've been with HP Agilent Keysight for 42 years. Started in power products and had a hand in a lot of the power supplies over that multiple decades. But since then, I've gotten into a broader focus on all of our general purpose products, function generators, data acquisition, voltmeters, not just power supplies anymore. So we were looking for a way to increase the opportunity for our customers to use our products. And we had an obvious gap at the lower price points. And the challenge is we could OEM somebody else's product, but it wouldn't be the same. It wouldn't be that Keysight experience that we're trying to maintain. We take it very seriously how we bring that to the customer. And the challenge was figuring out a way to take that and meet the price points we had to hit. So where I got involved, I'm kind of the guru of cost. That's one of my areas of focus. And I actually work very closely with our manufacturing teams for these products, the same manufacturing team that developed our new low-cost scopes. And we also wanted to get into the market very quickly and move fast, but preserve that Keysight feature and feel. So what we were able to do is we were able to find a way, and this was really a big part of my job, was how to leverage our higher-end products that cost more and can do more, but bring that technology and the capability into this price point. So I spent quite a bit of time with the manufacturing centers figuring out how to change things and lower cost, but also to leverage the best we had before. So what you get with these products is that same Keysight user experience, the same user interface experience, which we've already spent a lot of money on, just like our scopes, and also some of the performance characteristics that we are world leaders on, things like true form technology and our function generators, are in these products. In some cases, we actually use the same chipsets to generate signals or to make measurements that we use in our other products. So that's really my role, was to figure out how to put the package together to make it happen, and then work with the teams to bring it to market as quickly as possible.
So you said you're the guru of costs. Does that mean we can blame you if things are too expensive?
Absolutely.
Can you talk a little bit about how these are the same as their bigger siblings, and how are they different?
Sure. Well, they're obviously different in that they have big screens. And that was a key aspect that when we started to talk to customers in the education and the low cost segment, these are customers who are not as experienced using equipment typically. They don't have as much equipment on their bench. They're not looking at fine detail. They're looking at more basic capabilities. And we saw, for example, a typical education lab was 4 engineers sitting at a lab with an assistant behind them looking over their shoulder. And we realized that some of these small displays were just not adequate for that. And frankly, going to the large screen makes it much, much easier for people who are less experienced to really understand what they're looking at. Thing like a voltmeter, big numbers in front of them, easy to keep an eye on. Power supplies off in the corner. You can see the status, you can see the current readings very easily on that large display. The function generator, building a waveform, it's complex. And especially if you're doing, surge, pulse, that kind of things with the function generator, building that waveform, that great big screen makes it much easier to use and understand. So that was part of, we wanted to bring that to this market in a new way that really brought something special to the marketplace. But we also wanted to take our existing capabilities that we had developed on our smaller screen, higher end products, that we wanted to kind of preserve that. So we spent a lot of time coming up with the user experience that we had on those products and transferring it to these as effectively as possible. So if you look at our higher end voltmeter, our higher end function generator, our higher end power supply, they look very similar. That's not by accident. We said we had something good here, we want to bring it to here. And I think we succeeded and added the big screen experience to make it even easier to use. So these products are probably the easiest products we have to use in our entire portfolio.
I would agree. I've been getting some behind the scenes time with them, and I've been waiting for products like this for a long time from us, because I know a lot of people they don't even necessarily think Keysight with an affordable bench, but so I'm really excited to have these. But at the same time, how much are they sharing the same guts, the same chipsets, the same engineering techniques?
Well, it differs by product. We make higher end DMMs that use a different chipset, but we have products that use this chipset in our DMMs. In the function generator, it is the same chipset as our higher end function generators. It's the same true form signal generation technology that's the best in class, lowest distortion, best phase delay, most repeatable, all that good stuff. The power supply is actually the closest to the design of our higher end, smaller screen display products. It's very, very close to the exact same design. Just redesigned to lower cost, build on the bigger screen, but for the most part, the power supply is very close to our other product. Slightly less in terms of absolute performance. We had to cut some things to cut the cost, but not much different.
Yeah, so there's definitely a difference in performance, which is normal for any sort of line of equipment like this. But how much attention to like detail and quality do you see put into these compared to their bigger brothers?
Well, we run all of our products through the same gauntlet of hardware qualification, environmental qualification, and software qualification. We didn't do anything less on these products. We've got the same safety certifications worldwide, all those kind of things. They didn't get any get out of jail free cards for sure. We don't do that. Every product gets the same scrutiny, the same thermal margining, all the airflow verifications, they're identical. We really don't cut any corners. They are the same high quality products that everything else we sell goes through.
That makes sense. What about, so they all say EDU at the top, and you mentioned they were designed where you have 4 engineering students sitting in a lab trying to use the same piece of equipment. Mm-hmm. What about the other side? What about outside of the education lab? Where else do you see these being used and being useful?
Well, we were talking about that earlier before we started this. There are people who work from home now more than ever. And for example, I'm a hobbyist. You can see behind me, I have equipment on my bench. And I know several friends of mine who have bought the scope, which has been out for a while. And I expect that some of them will be buying the power supply. In fact, I happen to know somebody who bought one of the power supplies already, and the function generator and the DMM, because they're cost effective. They're competitive with what used to be, we had to buy inexpensive products from companies that aren't as reputable. You can now buy Keysight products for the same price points that you could get those other products for. So you're going to see hobbyists, you're going to see people working from home who want a good product on their bench, and these are very good form factor, big display. They're shallow. We don't have products like that in any performance level until these came along. They fit better in a small bench. As you can see, my bench is quite small. I don't have the space. In fact, the scope I have is way too deep and takes up way too much space. I would love one of those on my bench right now.
I'll get you a scope, John. We'll get you covered. Yeah, and one of these is a scope. It's hard to tell from the back. These three are all the same looking form factor, especially from the back, and the power supply is only a couple inches deeper. I assume, I haven't gotten to take it apart yet. I'm waiting to. I assume it has the big donut toroidal transformer in the back of it too?
Correct. It does, yes.
Yeah, those things are a sight to behold. I'll have to pull it out.
Part of the effort to get these to market quickly was to reuse a lot of the tooling. So that front frame that was developed for the scopes was designed in multiple pieces to allow us to replace the key layouts for different products. The screen area with the soft keys is the same. That's hard tooled, but the key area and the knob area and the connector area along the bottom can be changed for each of the four products. So they actually use the same tooling to manufacture all four of them.
That's pretty cool. I was wondering about that because the buttons are definitely different. There's definitely differences, but more similarities than differences for sure.
Mm-hmm. Yep.
And Dave Jones, who you spent, there's 2 hours of interview with you in Australia with Dave Jones, which were a great
guy.
Great watch. He caught on when we first released the 2-channel scope. The front panel actually had 4 holes for 4 channels, and we just covered it up with a label. And it's the same sort of thing. Is that helps us lower the price for these so that they're still functional, and we don't have to retool injection molding or whatever we use. On the control side, you talked about UX. These all have a LAN port. Can you talk about the importance of being able to control instruments remotely and connect them up to a computer?
Sure. So, obviously a long time ago, the world used GPIB. And GPIB for its time was great. However, it was slow. You can't move data faster than a megabyte per second. It requires really big and wonky, expensive cables that are difficult to run long distances. And today, PCs are more closed up. Today, people use laptops. So you have to buy a very expensive USB to GPIB interface if you want to use GPIB. So today, people don't want GPIB. If they used it in the past, they continue to use it. And there are a few aspects of GPIB which are kind of nice. But for the most part, LAN and USB have replaced it for most users. USB more commonly in the small labs and LAN in larger systems. And the reason for that is LAN can have lots and lots of addresses. LAN is very fast. Gigabit LAN is, 100 megabytes per second. 100 base T is, 10. That's way faster than GPIB. Even USB, 480 megabits per second for USB 2, which is, what we support. That's plenty fast enough for most of these applications. And the cabling is inexpensive. And you already have a LAN system built into your computer or a USB system built into your computer or both. So you don't have to buy an expensive interface to use it like you did before with GPIB. There is one other interface that's still out there, which is RS-232. And last time I checked, there are no RS-232 ports on any laptops or PCs anymore. That's another expensive card you have to add. So it's still used by a few people out there, but mostly for long, cheap cable runs for very slow equipment. It is really slow, frankly, and fairly noisy. So for the most part, people are switching to USB and LAN, and we're going to serve whatever they need to use the most inexpensively and the highest performance. It's way less expensive, frankly, for us to put LAN in a product than it is for us to put GPIB in a product. Just the GPIB connector alone costs more than all the LAN circuits in the box.
I posted on Twitter in late January. I found a USB to GPIB cable in an electronic scrap bin, and I pulled it out, and I was like, "Look what I found!" And the ire of people towards GPIB in 2021 has been surprising. How much people were like, "Get me away from GPIB."
It's actually interesting, though. If you talk to people with GPIB, there are some benefits to it. It's by far and away the simplest thing to set up and use. You put an address, and it's at that address. So LAN is a little bit more mysterious, as is USB. How to find it and talk to it. We have a great tool, Command Expert, which makes it very easy to find all the equipment on your LAN or USB hookups and know which address they are. But you have to have a software package like Command Expert to do that. You don't need that with GPIB. So there's still some diehards out there who just like the sheer simplicity of it. It just works. They don't need the speed. They already have a box of cables from decades of using it. So we still sell 10 to 20% of our customers want the GPIB interface. So if that's what they want, that's what we'll give them.
Sure. So now as we've pretty much switched over to Skippy commands as the control, is it always Skippy commands? Was there a different command protocol?
There were some proprietary command languages in older products. There was an HP multimeter language, and there was a few others, but that's why we started Skippy. It used to be called HPSL, and then when we developed it, we moved it to Skippy, made it an industry standard. Today, no one does anything but Skippy. In fact, Skippy and LXI, LAN standards for communication are built around LXI.
And you were instrumental in the creation of Skippy commands, is that right?
Yes, I was actually on the committee that developed Skippy. I was the power supply representative, and it was a very interesting process developing the command language because we obviously make some very, very expensive products that wanted a lot of capability, standard, required. And I said, I don't think we can fit that in a power supply without adding a lot of cost. And us and the voltmeter team and a few others that had low-cost products really pushed back. So we tried to come up with a standard that could meet the needs of something as expensive as a $100,000 network analyzer and a $1,000 voltmeter. And I think we've succeeded to the point now where no one makes programmable test equipment without Skippy. I mean, it is the industry standard.
Yeah, I'd say that's pretty universal. I can't think of any that don't have it unless they're, from back in the day. So we've talked a little bit about connectivity. So the natural next question then is manufacturing environments. What are customers looking for and equipment users looking for from a product in a manufacturing environment?
So one of the revelations that we had about five years ago or so was for the longest time, we developed a single product that served both the R&D bench and manufacturing. And there was actually kind of a point where we realized we weren't serving either one well. So for example, in R&D, the form factor wants to be shallow with a big screen and lots of buttons and knobs. Okay. In manufacturing, you don't want a big screen and buttons and knobs. You don't need them. You want minimum rack space. You want it to be rack width, and you don't really care so much about depth because racks can go 24 inches plus deep. So we've made a decision to kind of develop independently products that are well suited for R&D benches and products that are well suited for manufacturing. So we have lots of products. In fact, our power products, we make the world leading 1U 4 output product, the 6700 family, and we're moving in that direction more and more with our other products. In addition, we've focused a lot of our new energy on PXI, which is very similar. There's no front panels on PXI. However, in R&D, you want shallow, you want big screens, you want large buttons and knobs. People's hands determine how big the buttons and knobs should be. You don't want to have, like an old tech scope used to have, these little tiny buttons and trying to operate that. That's not a good experience. It's easy to make accidental button presses. I don't know if you've ever hit the auto button on a scope, but you can regret it 10 minutes later before you're back to where you were before. Okay, so we really wanted to focus on human ergonomics and make it easy to use. So with these products, we probably got the best we've ever achieved with that because we weren't trying to make a product that could go into manufacturing with the same form factor. So we have those other products in our catalog. We've been making them for decades. We're moving away from that. We're moving toward unique form factors for each of the two experiences to really optimize. However, inside and the Skippy command set and the usability from a communication standpoint, they're identical. So you can develop your code on the bench, you can move right into manufacturing with it, and you can know that it's the same fundamental measurement technology. So you won't get glitches. Oh, it makes a different measurement with this box than it makes with this box.
That makes sense. So we're kind of on that UX talk now and topic. What about these is optimized for UX, and how do you go about actually developing a UX that feels natural, hopping from a scope to a DMM to a power supply to a function generator?
Well, obviously, all four have the same soft key-based interface. Now, there are many different ways. People can use touch. They can use soft key. We've done some touch, and obviously the higher-end scopes have a lot of touch, and we're certainly looking at touch. And some of our competitors have come out with touch. What we find is that touch isn't always optimized for the bench. In fact, Steve Jobs said, there's a famous video on YouTube you can see of Steve Jobs when they came out with the iPhone. He said, laptops, touch is bad. In fact, a lot of people who get touch screens on their laptops turn it off. What you find is, unless you can control the angle and the distance to the device you're touching with your other hand, it's very difficult to get alignment between your touching finger and the thing you're touching. So, for example, our higher-end scopes that have touch have a tilt to them so that the screen is more angled to make it easier to target screen. In addition, touch requires you to have very, very large features to make it easy to hit them reliably. That lowers the density of your screen, and it makes this high-resolution screen you paid big bucks for much, much less useful. So it's actually preferred in many ways to have buttons and a dedicated screen. In fact, one of the most famous examples in the car industry was the BMW iDrive. When they initially came out with it, they put everything through the iDrive. Today, they've pulled out the commonly used features into real buttons and knobs. And all the car manufacturers who were running toward touch screens and knobs and buttons, iDrive type solutions, have since pulled back. And your climate control, your volume for your radio, they're not in that screen anymore. They're brought out separate. So, and I think the Scopes team was really one of the first that understood this better than anybody in the company, to make sure that we make it easy to use with dedicated knobs and buttons. So, for example, the power supply has 2 knobs. Now, why do we have 2 knobs? Well, it turns out people want to change voltage and current, and they don't want to toggle between them with a single knob. And the reason for that is, what happens if you wanted to change voltage and you accidentally changed current? Or even worse, what if you wanted to change current and you turned the voltage up and blew out your circuit? So we have a dedicated voltage knob and a dedicated current knob. Yeah, it adds the cost of another circuit, another optical encoder or mechanical encoder. But all the testing we've had said, no, power supplies need 2 pretty good sized knobs, far enough apart so you can get to them without bumping the other one accidentally. So we've spent a lot of time looking at how users use their products. And with these products, because they're bigger, they're designed for R&D, we could actually space things apart, make them more ergonomic and easier to use, more reliable to use, which was kind of cool in the end. People are finding they prefer these over the other products that have the smaller screens and the smaller displays and the smaller buttons and knobs. They prefer these over the others.
Yeah, I'm curious to see the reaction overall, because I think in the long run, history will show that we all like the bigger screen, but I'm sure there will be people who are not thrilled with either the height or just the size of the screen in general. Do you have any comments or what would you say?
Well, we have those products. We have the smaller screen. We have the more dense footprint on the front, the 2U half-rack size products. We have those products. They're not going to go away. We're going to continue to develop them. There's people who love them. They have much smaller screens and smaller buttons and knobs, and you can stack them up and fit a whole lot more on your bench with them, which is a benefit. If you don't mind the depth, fine. If that's what you want, we're there for you. We have a product that meets that need. I don't see that going away anytime soon.
Speaking of UX, can we talk about a dial knob versus a twist knob? I've always kind of wondered that. This is
a dial knob versus a twist knob.
So this has like the function generator has like the knob with the indent that you twist. You put your finger in and like a rotary phone almost.
Right. So when people use a function generator, they use it quite often in a very specific way. They inject a signal into their circuit, and there's a certain frequency, a certain point. Maybe the amplitude causes something to happen, or the frequency causes something to happen, or the phase, whatever it may be, where it bursts into oscillation, or it blows up, or it overshoots. So they want to kind of hunt in for it. And that's where that indented knob is very, very useful. Okay, power supplies, not as much. Obviously, if we had the space, we had unlimited space, we might put one on the voltage, not so much on the current. But for the most part, that hunting process, that zeroing in on a narrow range of operating point, is not as common on the other products. Some of our early prototypes of our DMMs, we had knobs on that too, and all of our exhaustive testing said, no, that doesn't make sense. So I had a prototype, in fact, I have one here, it's not with the knob, but we had prototypes on some of the knobs, and we went back to the crosshatch, the arrow up, arrow down, left and right. It's the better way on a DMM, because you're picking fields, okay, you're picking ranges. You could do it with a knob, but it's not the right way to do it. When you do enough testing, people say, one of the problems with a knob is you always overshoot a little bit, right?
Yeah.
Okay. Whereas if you have an arrow key, you tend to get there and stop. So there's things like that. You study how you watch people using it, you watch them making subtle mistakes. They'll get to the end goal. That's not the point. The point is, how easily did they get it? How reliably did they get it? And the indented knob, people use that function generator. They want to, right there. That's where it's bad. Look at that spike shoot up when that happens. That's the product that needs that kind of a knob.
Interesting. That makes sense. Yeah, I feel like UX is one of those things that if it's really good, you don't think about it or notice it, but it only sticks out if it's bad and annoying. So,
well, one of the simple things we look at is how deep are the menus, and are the menus rational? Do I expect to find this under that menu? One of the things, people don't read the manuals more and more now. They just don't. So you got to expect that one of your goals in designing the front panel and the user interface is so people find the functionality where they expect it to be. And the words you use in all the menus make sense to guide you into where the next thing is. And that takes a lot of time. And sometimes you can get alternative paths that both make sense, and you have to kind of make a decision one way or the other. And invariably what you find is that if you make the decision way A, and then you go to add an extra feature, you go, now A is no good anymore. And what often makes the best solution is the one where it doesn't break as quickly. Whereas as you add new things to the menuing system, it's more natural to where it goes. You start realizing you kind of created something that guides the customer to the right features no matter what we add to the product. Whereas if you have a bad, tree, so to speak, it may feel good for now, but as soon as you add a new feature, where can I put this? There's no good place for it. And you have to go back and redo it. And it's really interesting how that kind of falls out. And it's not easy to do. The people, what's wrong with this one? I go, well, I don't know, but I don't like it. And you'd be surprised at how often the proof is in when you add the next feature. You realize that you have it right because it falls into a natural place, or it doesn't fall into a natural place.
That makes sense. That's interesting. I never thought about the roadmap being a UX factor, but that makes perfect sense.
Oh, it's very much. If you make something 5 menus deep, no one will ever use it, and they'll never find it because no one likes to hunt. People hate, not only do not read the manual, but people with test equipment in particular, especially power supplies, are afraid to start poking down into the menu system because they might turn something on they didn't want to use, like, too much voltage, something like that. So they're very
sure.
quick. Same with the function generator. They don't want it to go up to the highest frequency or, start sweeping accidentally. So they're often afraid to surf the menus. It's kind of, especially when it's hooked up. If it's not hooked up, sure, they'll play. But even then, you would think engineers are inquisitive. They're actually very conservative, many of them. And you have to make it very clear where everything is. And, there's 2 parts of usability. There's learnability and usability. Usability is once you know it, you can find it again quickly. Your car is a great example. You don't look at the controls in your car when you're driving, and they constantly change where the high beams are, and they move around the radio controls. But once you have the car for 3 months, you know it. So it's usable, okay? Learnability is the first week you have the car, okay? How quickly do you find the functions? And I have a bad story. My new car, I just got a new car in September. Haven't driven it much. And one of the most basic features is the interior lights turn on when you open the doors. I just figured out where that was because I refused to read the manual last week.
Yeah,
and it's in the most non-obvious place. It's not near any other lighting controls. It's up by the sunroof controls.
Oh, no. I'm unfortunate in that my car is of the era where touchscreens were new and cool. It's like just pre-iPhone, and they buried the way too many things in the touchscreen, and it's infuriating to use.
Yep.
Drives me crazy. So as we wrap up on time, is there anything about the Smart Bench Essentials that you want people to know as a big takeaway for these?
So I think one of the things I want to make sure people understand with these products is we didn't design a cheaper product. We designed the same kind of product we always design. We reduced some of the specifications so we could save some of the cost on some of the precision components, which we use in all of our products. But the fundamental way the products work is the same. We use, in many cases, the same chipsets, the same fundamental circuitry, the same quality components, capacitors, transformers. You mentioned the big toroidal transformer. We didn't cut any corners on the quality standards, the temperature rise on our parts, the voltage derating on our components. That's standard across all of our products. We did not make this going to die in a year. It's not meant to be that at all. This is meant to be as reliable. And if we say it meets that spec, it meets that spec for as long as we say it meets that spec on any other product. The calibration, quality, the standards, these products can meet ISO 17025. No problem. No, I'm very proud of these products. We all are very proud of the team. Worked very, very hard to bring these to market. We think we have the strongest position now in education and for low-cost entry products. And we think these are going to do great in the market, and customers are really going to love them. And the orders have already been off through the roof, which we're really happy about. We think it's going to be a great add to our product and keep us in not just for the expensive. We're known as the most expensive, but with these, we really tried to break that mold.
Yeah, I had a couple family members that were engineers, and they're like, "Oh, HP, yeah, high price. You can't buy better, but you can't pay more." I'm sure that's an old joke, but it was new for me.
Well, and certainly we have lots of products that fit that, but for these, we really felt it was important to have products that, when you're starting out, some of our competitors have figured this out way ahead of us. That if you can get kids in school to use your products, then they desire those same products when they get out of school. And just the fact that we have some of the best user experiences, that's something that sticks with you. Once you've used a product that has a great user experience, that's what you want to use going forward. That quirkiness, that weirdness that you get with a not so well designed product, it becomes a real detractor. And that's when you want that going on. So we really feel like we've achieved that. We've kept that same easy to use feel. The quality is there. So we think this is going to make it easier to keep people in the tent and make them Keysight customers for life.
Well, thank you so much, John Kenny. I really appreciate having you here. It's been an absolute pleasure speaking with you. I've been looking forward to this for a while, so it's kind of a
cool. Appreciate
bucket list interview for me. So thank you so much for your time.
Yeah, sure.
Each day, we also have a quick highlight of a Keysight solution. Since today is the first day for the Smart Bench Essentials, it only makes sense to start with these. The product manager for the Smart Bench, Gobi, put together a quick highlight video that talks more about these. Let's take a look.
Hi, I'm Gobinath Tamilwanan, the product marketing engineer at Keysight Technologies. In this short video, I'll introduce the latest revolution to bench test equipment for your lab. We call it the Smart Bench Essentials, a set of 4 instruments including a digital multimeter, a power supply, a function generator, and an oscilloscope. Plus powerful application software enabling you to connect in new and unprecedented ways. Test your next innovations from anywhere, at school, the office, or from home. With remote access software, Smart Bench Essentials enables you to test faster and more accurately than ever before. The Pathwave BenchView application software included with Smart Bench Essentials configures your instruments quickly and lets you operate them from your PC. This powerful software provides you with integrated instrument control, auto data logging, remote data access, and easy file sharing, all on one PC. The Smart Bench Essentials series also comes with the optional Pathwave Remote Access Lab and the Pathwave Lab Manager software to enhance your lab experience and your productivity. Pathwave Remote Access Lab provides a way for higher education labs to seamlessly move to online learning. It allows students to remotely access their lab setup and perform lab work through a web browser. Pathwave Lab Manager enables you to effectively manage your lab assets through the Pathwave Cloud application. It allows smart tracking, maintenance, firmware updates, and lab asset sharing. And finally, when paired with Keysight Care service and support, you will have all the answers you need when you need them with proactive support through a single point of contact. But that is just half of the story. The 5.5-digit dual display digital multimeter provides industry-grade measurement capabilities with an intuitive front panel. It measures 11 different input signals featuring 5.5 digits of resolution and a measuring rate up to 110 readings per second for speed-critical tests. The function generator offers all the standard signals and features you need today and expect for testing tomorrow's designs. It has 17 built-in arbitrary waveforms and 6 built-in modulations to get you set up and testing immediately. The triple output DC bench power supply is ready for your next design with its 90-watt electrically isolated channels that supply clean and reliable power. You can independently turn the outputs on or off to give you 3 power supplies in one. And finally, the 50 MHz oscilloscope provides common built-in signals, enabling you to quickly capture and analyze signals. This oscilloscope even offers body plot functionalities, a critical measurement to characterize amplifiers, passive networks, and power supply feedback networks. With signature large 7-inch LCD displays, backlit buttons, color-coded input and output connectors, a consistent graphical user interface, and the same software across the entire platform, your instruments will truly be connected to you and to your next innovation. This connected hardware and software ecosystem makes the Keysight Smart Bench Essentials a truly connected experience.
We've had some great questions come in on the chat throughout the stream so far, and I'll take some live questions at the end of this stream, so put those in chat now, and I'll get to those in just a moment. First though, it's time to draw the rest of today's winners. We already picked 4 winners in the Perfect Test Bench video that is normally lower down on the webpage. As you know, if you're watching this live, we've had some server issues, so thanks for bearing with us. Each of those winners got their pick of one of the Smart Bench Essentials test gear. I'm going to pick one more winner today who will get their pick of these, and we'll also draw our first prize winner. The first prize winner gets their choice of a 3000 T-Series oscilloscope, a signal generator, a function generator, a benchtop DMM like the one under my computer, or an electronic load. And 3 more winners today will win a U1282A handheld DMM. And on Friday, we are picking a grand prize winner who gets their choice of a 2.5 GHz EXR Infinium oscilloscope, a 6 GHz 6000X series Infinivision oscilloscope, a 9 GHz Streamline USB vector network analyzer like the one over here, or a 26 GHz FieldFox handheld microwave analyzer. We'll be back at this time live every day this week. That's 10 a.m. Mountain Time, -7 UTC, and we'll have all the server stuff figured out at that point. And then we'll be back weekly each Tuesday until the end of April, starting next week. So put a reminder in your calendars for 10 a.m. Mountain Time, -7 UTC every day this week, and each Tuesday at that same time until the end of April. Okay, the big moment, time to draw today's winners. We get a lot of questions about how we're drawing prizes. We make sure that it is sufficiently random, and every entry, everyone who signed up, is eligible for every drawing. So you don't have to come back and sign in every day or anything like that. Okay, the first prize winner is Derek Roger. So you get your choice of one of the scopes, DMM function generators, like we talked about, not one of the Smart Bench. The Smart Bench winner is Baron Dennis. Baron, you get your choice of one of these. And then the U1282A prize winners are Wayne Greiner, Tarek El Kahel, and John Penven. Congratulations to our winners. That's the end of our formal stream. Thank you all for bearing with us as we worked out the servers. There are just so many excited people joining in today. It crashed our webpage. So thanks again for bearing with us. We are thrilled to have a problem like this, but we'll have it back up and live tomorrow. There's teams scrambling on it. So it's time for some Q&A. The chat has been monitored throughout this stream, so the team has been pinging me some questions. So I'm just going to go in and start asking questions or answering questions. Someone asked, what do I recommend for someone who just started building a lab? We actually posted a video earlier today on the Keysight Labs YouTube channel. It's also going to be at the bottom of the Keysight University Live page when that's up and running. That goes through everything I think that you should have in an electronics lab. And there's even a scorecard you can download and mark your scores. So that's where I recommend you start. It's fairly comprehensive and covers pretty much everything. Questions about whether or not you can remotely control these. Yes. So pretty much every piece of Keysight equipment, even these, have some sort of remote control connection. The back of these, if I were to turn them all around, have a Ethernet port. You can control them over USB. The DMMs, there's like a Bluetooth attachment so you can run it from your phone. You can actually see that in the earlier YouTube video from today as well. You can do remote lab work, so if you have someone hook it up in the office, especially when we're all working from home, the ability to see other people's benches and connect and control equipment that's not right in front of you has been super helpful. That's something we have on pretty much everything. Skippy commands, internet, USB, or Ethernet and USB. What are my thoughts on benchtop devices with a touchscreen? Is a question that came in. I like it a lot. These don't have touchscreens. Some of the ones behind me do. touchscreens are one of those things where I think we're all so used to using touchscreens now that it's just a normal way to interact with a screen. Even like my laptop is touchscreen, and when I'm at home on my desktop, I try to touch my monitors and get smudges on them. I really like it. I think there are times when you don't necessarily want it. So if it's a benchtop tool, I think Kenny talked about this not just earlier in the stream on the interview about different use models. So when you're in the bench, it's nice to have a nice big screen and to be able to control it intuitively. So I like the touch screens. I don't always use it, but it is nice to have occasionally. So that's my take on touchscreens. Everyone kind of has their own thoughts on that. Man, we got a lot of questions. This is great. What's next? Someone asked, does Keysight have 500 volt to 1 kilovolt differential probes with a bandwidth more than 200 megahertz? I'm not sure specifically on that, but we have a ton of oscilloscope probes. So if you just search oscilloscope probes, it pops up right at the front. Or go to keysight.com/find/probes, probably will work. There's a whole list of probes. There's like a catalog. You can go through the specs. The hard thing about probes is when you have a really high voltage swing like that, you're probably doing like gallium arsenide FET switching or something like that, like high power. The big swing is hard to get fast bandwidth at the same time. So 200 megahertz it's a really tricky probe to build. Let's see, what else? Someone asked if their lab score affects their chances of winning. If you scored your bench, that does not affect your chances of winning. It's a completely random draw. Everyone has more or less the same chance, and I say more or less because you will each have a URL specific to you, and if you refer other people to sign up, so send it to your coworkers, your lab mates, and if they sign up, then you get an extra entry as well. So some of you can get a few more entries that way. Don't spam it, because we can see that. We do vet all the winners as well. What other questions do we have? What are the key hardware differences between the SmartBench Essential series and their bigger brothers or siblings? Like John said in the interview, I think I called him Kenny earlier, there are some differences, but they all use the same core technology. So we're gonna, as these just released today, but in the future, we're gonna release some comparisons so it'll be easier to tell. These do a lot of the same things that their bigger ones do. The bigger ones will do more advanced analysis. So like this function generator versus this function generator have very similar like signal performance, but this one, for example, you could like do a 10-degree phase shift 5 cycles into a sequence and get really, really complex with your testing. This one doesn't have quite the same advanced features. So you can check out data sheets if you're really looking and trying to figure out which one, and we'll make that easier for you in the future. On day one, we don't have that right now. But we will release that. We'll write up a blog. Blogs.keysight.com has all kinds of information on these, and we'll get something up on that pretty soon. What else? Oh, someone asked about the touchscreen. Does it interfere with the oscilloscope? The only time I've seen a touchscreen interfere with the oscilloscope is if you have a touchscreen, and because we use capacitive touchscreens, because resistive touchscreens are nonsense, the only time I've seen interference is if you hold it right up to the screen. The capacitive touchscreen electronic stuff can interfere with it a little bit, but as soon as you get more than a inch or 3 away, it goes away. You can also turn off the touchscreen altogether with a hard button on the front panel. You just click it and it turns off touch, and then all that interference goes away. So it's kind of the best of both worlds as well if for some reason you're testing right in front of your screen. Remote monitoring is possible. Each of these come free with their own app, and we're going to look at that a little bit later in the week, especially on the function generator. We're going to control an RC car with the function generator. I'm super excited about that video. And they all come with desktop control apps that you can access them remotely. You can control them in-house. You can also do some signal parameter tweaking and adjust settings through the computer. What is the difference between a signal and a function generator? That is a great question. So I actually put a poll out on Twitter a while back to see, what do you call it? Do you call it a signal generator, function generator, waveform generator? What's the difference? A function generator is a tool that creates a waveform based on a mathematical formula or equation, or you can just go set it to sine wave, triangle wave. But generally, a function generator is a time domain signal generation device. So it's going to put a signal out that maybe you want to put a clock signal into your board, or you want to do some serial data simulation, something like that, or just a sine wave even, is where you'll use a function generator or a waveform generator. A signal generator, generally if you hear signal generator, that's going to be RF. So a signal generator is generally geared for RF testing. So the bandwidth will be, or the frequency ranges will be a little bit higher, and it'll do a really nice sine wave over a frequency or a spread of frequencies, like a bandwidth section of frequencies. So, testing like 5G, LTE, Wi-Fi, Bluetooth, all those need a signal generator to test the antennas and the receiver systems so that you can actually send data. So signal generator, think RF testing. Function waveform generator, think like electronics digital testing. That's a really good question. If you want more RF videos, let me know in the chat as well. How long does it take to develop the next generation of Keysight instruments? I did not see that question, I promise. It takes a while because we use our own chipsets. Like on the other side of this wall over here that you can't see is a whole team of people that design custom Keysight chips just for this equipment. So you can't even start really building hardware until you have a chip. So the chip takes a while. Just designing a custom ASIC takes a long time, especially if it's complex. And then you have to integrate that chip into an actual product, which has like front end and DACs and ADCs and all kinds of processing. So it takes a while. It really depends. Something like the UXR is our 110 gigahertz oscilloscope takes a really long time. Something like this, we were able to get out a little faster just because we had a lot of the technology blocks. So we had, we borrowed a lot of the technology from these and shoved them into here. So it was easier to build. And you get the benefit of having the same chipsets as a higher end piece of gear. Great question. When will we reach 100,000 subscribers? They're asking about the YouTube Labs channel, or the Keysight Labs channel on YouTube. I'm really excited about that. I think we're going to hit it pretty soon. And if we hit 100,000 subscribers during this event, we're actually going to give away a little bit of extra gear. So make sure you are subscribed to the Keysight Labs YouTube channel. I want that silver play button real bad. So, good question. Does Keysight have programs or ways to help students get introduced to EE, electrical engineering, or something along those lines? Yes, we launched about 8 months ago Keysight University, this is kind of an extension of that in a way. This is Keysight University Live from the lab. We also have Keysight University. If you go to learn.keysight.com, there are a ton of courses that go over test gear and technologies, and that's a really good way to kind of brush up on what's happening in the industry, build out some of your fundamentals, especially in domains that you're less familiar with. So like if you don't know RF, there's some really great RF courses over there. One of my favorites is a 5G course series that we put together. We have an intro to 5G, which is like I think a 30 or 40 minute course, but we have like 5 or 6 or maybe even 8 now courses that go into different 5G technology blocks. I always had a hard time figuring out how 5G actually worked. It was just hype stuff. So that's a really good course to dig into at learn.keysight.com. Will there be scopes with wireless probes? We did an April Fool's Day video on that 2 years ago, I think, where we pretended to release one. Yes, it was 2 years ago. So if you search wireless probes in the Keysight Labs YouTube channel, you will find that. The problem with a wireless oscilloscope probe, so you have the probe, right? And the probe plugs into the front of the oscilloscope. It goes into a front-end circuitry, which processes the signal and feeds that into the analog to digital converter that then feeds into the processor. The problem with trying to do a wireless oscilloscope probe, and people have even marketed wireless oscilloscope probes, is for it to be truly wireless, you have to do all that front-end signal processing and analog to digital conversion in the scope itself. So you've basically taken a big portion of what the oscilloscope does and moved it into the probe, and now your probe costs as much as your oscilloscope, and it's really like an oscilloscope all by itself. It's more of a wireless oscilloscope than a wireless oscilloscope probe. So that's a good question. I always get a chuckle when people ask me that, because it happens. You're not alone asking that. Do you have super fine needle types of scope probes? If we can pop in on this tight camera here. This right now is kind of just standard probe. It's got the little grabby there and the ground clip. And on Wednesday, we're doing everything you need to know about oscilloscopes video. So you can learn more about that. But if you pull the cap off, then there is a fine needle type probe here. Yeah, so right about there. Can you see that? Okay. So you can see this is pretty sharp. The cap comes off. Normally it's a little grabby thing like this. So there are tons and tons of probing options. The probes also come with a lot of their own accessories. So there's extra short ground leads. And the Keysight Labs YouTube channel has a ton of probing videos. And over on Keysight University, there's a ton of probing courses there as well. So we have a ton of information about probes. Someone says they remember Scope Month, the original. Michael, I do too. Good days. This is kind of an extension of that event in a way, but we think it's bigger and better than it's ever been, as evidenced by our website issues this year. Oh, this is a good question. Am I wrong in thinking a function generator is a power supply with an extra layer to modulate its output? That's a really good question. And it's an important distinction because function generators are not power supplies. They really don't have a ton of output power, and I'm sure someone will come correct me in the comments, but really a function generator is more about outputting a voltage, and it doesn't care too much about the current. So there's even settings on the function generators where you can set the output impedance to 50 ohm mode or high impedance so that when you're inputting your signal, you're not driving a bunch of power and you're not getting mismatches. But a power supply really can just put out a lot more power than a function generator. If I turn these sideways, I think we'll go to our close-up camera again. Something worth noting, that's an oscilloscope. They all look the same from the back. It's a little tricky. Here's a function generator. It's about this thick. Here's a power supply. You can see the amount of power generation that goes in. This box is big because it has to be. There's a lot of complex electronics and heat management and just not even complex electronics, but just power generating electronics that go into something like this. There's a huge donut toroidal transformer in the back of it about this big. Whereas a function generator is more about getting the signals just right, getting really high quality. So that's a really good question. Definitely not the same. So you don't want to try to drive a bunch of power with a function generator. That being said, also when you're supplying power, you generally don't need like a really nice sinusoidal signal. You just kind of need DC power. So you could probably build an attachment that goes on the front. That'd be an interesting project. What else do we have? More quantum computing related episodes. We do have more quantum computing stuff coming on Friday. We're doing an interview with Liz Rooch, who is the quantum computing expert, or the general manager of the quantum electronics group here at Keysight. So that was a fascinating interview. And her team is working on some Keysight University courses around quantum. So in the future, we'll see some more quantum computing courses as well, which I'm super excited about. I think it's super cool. We also did a podcast on that a while back. There's a Keysight podcast YouTube channel, or if you search EES Talk Tech in your favorite podcast tool, EES Talk Tech, we have over 40, maybe over 50 podcast episodes where we interview experts, kind of like we did with John Kenny. And I'm even going to put some of those interviews over on the podcast. So it's a good place to go to keep learning if this is something. If it's not on Keysight University, you can check out the podcast. There's some really cool ones over there. How does a scope function generator differ from a dedicated one, hardware and design-wise? That's a good question. So part of the question is there's a function generator on the front of our scopes. This is a A model, so it doesn't have one. But if I were to grab one with a G model, I'm going to grab one with a G model real quick. How about this one? So this is a MSOX 3104T. This is what you could win as part of the day one prize. If you look at the front of this box, there's a function generator output port. And all of the 1000Xs, if they end in G, have a output port like that. But basically, it's a 20 megahertz function generator with arbitrary waveform generator. And the 4000 and 6000 X series scopes actually have two outputs. They're just not as good as a dedicated function generator. So they're really nice. They have a lot of capability. They have an ARB in them. You can save a scope trace to the ARB and plug it back in, which is pretty cool automatically. But the signal quality and fidelity is not as good in an oscilloscope dedicated function generator as you get in a dedicated one. So it's kind of that same thing of the function generator is narrow and the power supply is wide. The oscilloscope only has a little bit of circuitry for the function generator, whereas the function generator is this whole box dedicated to getting a really high quality sinusoidal signal out. So that's a great question. What else? What are the differences between analog and digital instruments? That's a good question. At their core, a digital instrument is going to have an analog to digital converter, and it's going to send data, either analog data into a digital processor, or it's going to send digital data out to an analog front end. So if it's an input device like an oscilloscope, it'll take an analog signal in and process it digitally. An analog oscilloscope has no digital component, and it's all done on analog. So a lot of the, how do I put this gently, analog equipment is generally not as good, like oscilloscopes I think is more where I'm going with this, or like waveform generators. You're going to get a better signal from a modern digital scope than you would from an analog scope, just because the technology has come a long way in 20 years. We have like computers and smartphones now, and that technology advancement overall is reflected in the equipment. So I recommend starting with a digital device. Like if you're going to get a new oscilloscope, I don't recommend getting an analog oscilloscope as your first one. I'm sure people disagree. I'm happy to debate that off of the live stream because that's a deep dive. Lots and lots of questions. We'll run this for another couple more questions, and then we will wrap it up. Yeah, Gianluca says digital means 0 or 1. So yeah, digital is like digital data zeros and ones. So it takes a voltage value that's maybe 1.1365 volts and converts that into ones and zeros into some sort of packetized format. Yes, is there going to be a video or stream about VNAs? We are going to have VNA videos in the future. I got a VNA, I'm really excited, so I've been playing with it. Hoping to test some of DigiKey's cheapest antennas, so I'm curious to see how that video goes. We haven't filmed it yet. That'll be later in April or beyond, depending on how the research and writing goes for that video. What is the highest frequency scope you have? So the highest, really is bandwidth. We go up to 110 gigahertz, which is a beast of an oscilloscope. If you search for the Keysight UXR oscilloscope, you'll see that. We have I think a launch video where we looked at it's the fastest signals that have ever been seen on an oscilloscope. So at 110 gigahertz, a beam of light travels like 10 feet or something like that. Like it's so stinking fast. It's almost absurd. A couple more questions. What's the difference between gigasamples a second and 100 megahertz? So the question there really is, what's the difference between sample rate and bandwidth? We have, I think on Keysight University, definitely on the Keysight Labs YouTube channel. I did a video a while back about what is bandwidth and how is it different from sample rate. So if you search bandwidth for sample rate, I think our video actually shows up. Sample rate is how fast the analog to digital converter samples the waveform, but the bandwidth is more about how fast of a signal the hardware can actually handle. So if you search for oscilloscope function generator hacked, you can actually, I talk into that a little bit, where you can watch, we used an RF signal generator, plugged it into the DVM, the digital voltmeter on the oscilloscope, and you can watch the signal drop in amplitude as we exceed the bandwidth. And you can actually measure a pretty fast signal if you don't care about the quality of the signal. But bandwidth is about signal fidelity, and sample rate is about analog to digital conversion. So we have a ton of great questions coming in. We're going to wrap it up for today. Thank you so much for joining us. We're live every day this week at 10 a.m. Mountain Time. That's -7 UTC. So for those of you in Europe, it's kind of in your afternoon. So hopefully you can all be around for that. We're also going to work out our webpage issues if they're not worked out already. Yeah, we're live every day this week at kulive.keysight.com. And if you're on the live stream, we'll put a link for that in this video's description. Thank you so much for bearing with us. Thank you so much for joining us for the first day of Keysight University Live. I'm really excited for what we have in store. Tomorrow, we have a video about boosting the signal strength of your wireless car key. Super duper cool. We've measured car key strengths with a Field Fox, and there's some great learning and some great fun in that video. So I will see you back here live tomorrow. Thanks for watching. I'm Daniel Bogdanoff, and I'll see you then.